All right, so in Unit 2, Lesson 3, we're really going to start getting into the meat and potatoes of this unit on polynomials. So in this particular lesson, we're just going to learn about a few of the basic characteristics of a polynomial. And I have those up on my lesson notes here. So the degree, which is the first important characteristic of a polynomial, the degree is simply the highest exponent from all of the terms in the polynomial. So you might have 2 terms, 3 terms, 4 terms, doesn't matter how many terms you have. The highest exponent on x, or whatever variable you're using, is what we call the degree. So I gave a couple of simple examples here. You may remember learning about quadratic equations in Algebra 1 and geometry. Well, quadratics, the highest exponent is x squared. So those have a degree of 2. We call those second degree polynomials. And linear equations are first degree polynomials because that largest exponent is x to the first. So that's the degree. The leading coefficient is the coefficient of the term with the largest exponent. So whatever that is, whatever that the coefficient of that term is what we call the leading coefficient. And then the leading term is the term that has the highest exponent. So leading term and leading coefficient kind of go together with degree. The constant term is the term that contains no variable. So the term that doesn't have an x in it. So whatever the term is that doesn't have an x in it is called the constant term. And the reason the constant term is significant is it tells you the value of the constant term tells you the y-intercept of the polynomial. In other words, it tells you where the graph crosses the y-axis. Right? So that's what's significant about the constant term. It also, if there is no constant term, we assume it's a 0. So if you don't have a constant term, in other words, if all your terms have an x in them, then the constant term is assumed to be 0. Fourth, we have what we call relative max or relative min points. So those are points where the graph switches from going up to going down. In other words, high points, so that would be points where the graph goes like this, and low points would be where the graph goes like this. Okay? And we're going to use Desmos to help us with that. The last important characteristic are what we call the X-Intercepts, or the zeros, or the roots. They all mean the same thing. You're going to hear me use those 3 terms interchangeably. X-intercepts, zeros, or roots. They all mean the same thing. Okay? They all tell you where the graph crosses the x-axis instead of the y-axis. So our goal for this lesson is to be able to take a polynomial, graph it on Desmos, and to be able to identify the important characteristics. So that's what we're going to do here. For each of the polynomials, we're going to identify the degree, the leading coefficient, the y-intercept, the x-intercept, and any relative max or min points. Okay? And we're going to use Desmos to help us. So let's go ahead and start with this first polynomial right here. So that's going to be x to the 5th minus 4x cubed plus 5x plus 2. So the first couple we can do without graphing. So the degree, remember, is the highest exponent from the terms in the polynomial. So when I look at this polynomial for number 1, this one right here, okay, which term has the highest exponent? It's this term right here. And what is that highest exponent? It's x to the 5th, x to the power of 5. So we would say that that polynomial has a degree of 5. Okay? Leading coefficient. Leading coefficient is the coefficient of the term with the largest exponent. So the term with the largest exponent is x to the fifth right here. What is the coefficient of that term? Well, there is no coefficient there. So you might remember, if there's no coefficient there, we assume that the coefficient is a 1. It's 1x to the fifth, so the leading coefficient in this case we would say is 1. Okay? Now for the other three, for the y-intercept, the x-intercepts, and relative max or min points, we are going to use Desmos. So I'm going to take this polynomial and I'm going to graph it on Desmos. So x to the fifth, x to the fifth minus 4x cubed plus 5x plus 2. So plus 5x plus 2. And I can zoom in here so I get a better view. Okay. So what's the next one? The next one on our list was the y-intercept. Now the y-intercept we can find two different ways. We could look at the graph or we could look at the constant term. What's the constant term in this case? The constant term is the term that doesn't have a variable. So that's the 2. And if I look at the graph, does it cross the y-axis at 2? Yes, it does. So whichever way you do it, the y-intercept in this case is 0, 2. Okay, so that is my y-intercept. My x-intercepts, so those are going to be points where it crosses the x-axis. It looks like there's 3 of them. There's here, here, and here. So I'm going to write those down. So negative 1.585, 0. All right. Negative 1, 0. And negative 0.487, 0. So those are my x-intercepts. And then for relative max and min points, I'm going to look at where does the graph, where are there high points and low points in the graph? Well, for maximum points, there's one up here, and I see a high point up here. Okay? So those are going to be my relative maximum and minimum points. So my maximum points is going to be negative 1.365. Comma 0.609. Okay. And my second maximum point is up here. So 0.733 and 4.301. So 0.733 and 4.301. So these are maximum points. Okay. Minimum points are going to be these 2 points down here, these 2 low points. So there's 2, in this case, there are 2 maximum and 2 minimum points. So my first minimum point is negative 0.733. So negative 0.733, comma, negative 0.301. Okay. And my second minimum point is going to be 1.365, comma, 3.391. Okay, so these are minimum points. Okay, so I found the degree, the leading coefficient, the y-intercept, the x-intercepts, and the max and min points, the high and low points for the first one here. Now I'm going to do the same thing, but now I'm going to use this one right here. So my degree, again, what is my largest exponent? So that is my largest exponent. So the degree of this polynomial is 2. Okay, the leading coefficient, that's the coefficient of the term with the largest exponent. So this is going to be 1x squared. So this also has a leading coefficient of 1. The y-intercept is going to be where the constant term is. So the constant term in this case is 11. So the y-intercept is 11, or 0, comma 11. Okay. To find the others, now we're going to go to Desmos and we're going to graph it. So it's x squared minus 6x plus 11. So let me get rid of this. So it's x squared minus 6x plus 11. Let me make sure I copied that right. X squared minus 6x plus 11. Okay, so we can see the y-intercept is indeed at 0, 11. But if I look at this graph, does this graph actually ever cross the x-axis? Does it cross the x-axis? No, it does not. It actually, this particular graph stays completely above the x-axis. So it turns out that this particular graph has no x-intercepts. There are none. So this graph has no x-intercepts. Let's look for minimum and maximum points. So I see a minimum point down here at 3, 2. So I have a minimum point at 3, comma 2. Are there any maximum points? Well, if I keep zooming out, there never is a maximum point. So this particular graph is a lot simpler than the other one. It has one minimum point and it has no maximum points. So it has one minimum point at 3, comma 2 and no maximum points. So in summary, it has a degree of 2, a leading coefficient of 1. It has a y-intercept at 0, comma 11. It has no x-intercepts. It has one minimum point and no maximum points. All right. Let's do the last one. So 2x minus 5. So first of all, for my degree, what is my largest exponent? Well, it turns out only one term has an x in it. So that term is going to have the largest exponent. In this case, this is 2x to the power of 1. So it is a degree 1 polynomial. The leading coefficient, what is the coefficient of the term with the largest exponent? That's what this 2 is right here. So the leading coefficient is 2. The constant term is the negative 5, so my y-intercept is going to be at 0, negative 5. And then to find the x-intercepts and the maximum points, let's look at the graph. So it was 2x minus 5. And you can see, first of all, you can see the y-intercept does end up being at 0, negative 5. I see an x-intercept up here at 2.5 comma 0. So there's one x-intercept at 2.5 comma 0. And then for max min points, we have to consider the fact that this graph is a straight line. It's linear. Does a linear graph actually have a maximum or minimum point? Does it have a high point or a low point? And the answer is no, because it goes on forever in a straight line in both directions. So this particular graph, because it is linear, it has no minimum points and it has no maximum points. And we can say that confidently because it's linear. A straight line doesn't have a high point or a low point. In order for there to be a high point or a low point, there would have to be some sort of curve in the graph. Okay. And that is it for this lesson.